Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 students who are looking for a little more practice as they prepare for the EQAO. In particular, this video is related to a handout I gave with several EQAO practice questions, and it's video number 4 related to question 4. And here's the question. It says, determine the equation of the line that has the same y-intercept as 2x plus y plus 6 equals 0 and is perpendicular to the line shown on the grid. And of course, show your work. Okay, so a really classic analytic geometry question. So I like to organize my work. I find with a question like this, there's 3 lines being discussed. It's talking about the equation of the line that has the same y-intercept as this line as perpendicular to this line. So because there's sort of 3 lines going on, I find it really helpful to really identify what I'm talking about. So I need this line here, 2x plus y plus 6. I'm going to call that line number 1. Perpendicular to the line shown on the grid, I'm going to call that line number 2. And then the line I'm looking for, well, that's what I like to call my line. I'm looking for a line. I'm going to call it my line. So let's reread this now that we have sort of defined a few things a little more clearly. I want to find the equation of my line. And here's what I know about my line. It has the same y-intercept as the first line given and is perpendicular to the line shown on the graph. Okay, so now I can make sense of this. So let's talk about this first line given. So 2x plus y plus 6 equals 0. And what's important about this line is obviously the y-intercept. So I need to find the y-intercept of this line because that will be part of my line. So how do you find the y-intercept? Well, there's 2 ways. One way is to rearrange the line into the form y equals mx plus b, because if you have a line in this form called slope-intercept, then the b is the y-intercept value. So you could rearrange this until it looks like y equals slope times x plus or minus something, and that would give you the y-intercept. The other way of finding the y-intercept is to let x equal 0 and solve for y. And remember, the reason why that works is because the y-intercept means where does the line cross the y-axis, which I'm highlighting here in a very unstraight green line, but you get the idea. So if I want to know where the line crosses that, and let me put that back on. If I want to know where my line crosses this, what I know is that y-axis, every point along this now red line, is where x is equal to 0. So if x is 0, right, if x is 0, so it's not at 2, which is over here, it's not at 8, it's not at -6, it's at 0, then the y value will be somewhere on the y-axis. So the 2 ways of finding the y-intercept are that you can rearrange it and look at the equation, or you can let x equal 0. And the reason why I'm really emphasizing don't forget you can let x equal 0 is because if I wanted to find an x-intercept, there's really only one algebraic way to do it, and that is to let y equal 0. I can't rearrange this into any familiar form and be able to tell you the x-intercept. So because of that, I'm going to solve this one by letting x equal 0, because I think in general we did a lot of rearranging throughout the school year, and we did significantly less intercept finding. So let's use that method. Let me just clean up what I've got over here. Of course, whichever method you use, if you find the same answer as me, you've used the right method. But again, I'm going to use the method where I let x equal 0. So I'm going to let x equal 0, because if I let x equal 0, I can find the y-intercept. So I've substituted, I've substituted 0, that's a 6, not a b. I've substituted 0 in for x, and now the only unknown variable is y. 2 times 0 is 0, 0 plus y plus 6. So 0 plus 6 is obviously just 6. And then to solve for y, subtract 6 from both sides. So my y-intercept is the point where x is 0 and y is -6. And again, just to show you, if instead I had decided to rearrange the equation, let's do that really quick. So if I want to rewrite this into y equals mx plus b form, what would we get? Well, here's the y term, and it's plus 1y, so I need to isolate that. And everything else I want removed from the left, which means it'll show up on the right. So to remove positive 2x, I need to subtract 2x. To remove positive 6, I need to subtract 6. So there I've rearranged it, and now I can clearly see that my y-intercept is -6, just like I found over here. Those are your two methods for finding the y-intercept. So this line that said, the line I called number 1 has the same y-intercept as my line. So now I know, and I'm going to just write this on a new page, that my line has a y-intercept of 0, -6. And I don't need line number 1 for anything else. I've used it, I took its y-intercept, and now I don't care anything about line number 1. So I'm going to just delete my work so I have a clean space here. And let's talk about the other line that I need to look at. So what do I know about line number 2? Why is it important? So what we're told is that my line is perpendicular to the line shown on the grid. So here's the line on the grid, and my line is perpendicular. So what does it mean to say that two lines are perpendicular? So perpendicular, my favorite 13-letter word, means that the slopes are, and we use negative reciprocals. So just a reminder, what that means is that the word negative tells me that one of them must be positive and the other one negative. And reciprocals means that they must be the flipped fraction. So in other words, if I had -6/7, the perpendicular slope would be, first of all, it would be positive because it has to be the other polarity, and I would flip it, so it would be positive 7/6. And that reminds us that another way of thinking about perpendicular slopes is that perpendicular slopes multiply together to give -1. So let's look at what that means. So obviously, if I talk about perpendicular, I'm talking about slopes. So I'm going to find the slope of line 2, because if I know it's perpendicular, I know that's about slopes. So let's try to find the slope of line 2. So it's given to me on the graph, so I'm going to use the graph. So what I want to do is I want to find two really easy to look at points that I call lattice points. That point is exactly at 0, 4. That's a nice point. And this point is exactly here. So I don't want to use a point like this one, because that point doesn't fit exactly on the crosshairs of the graph, which means that I would be guessing where it was. Whereas a lattice point, like the two I've emphasized, I know exactly where they are. And there's another lattice point here, and there's another lattice point here. I could really use any of them, but heck, I picked those, let's go for it. So if I move the way a graph moves, which is from left to right, always, first of all, I have to go up. So it's definitely rise over run. So how much between this point and this point do I rise? Well, I go from here to here, which is from a height or a y value of 0 to a value of 4. So I have to rise 4. And how much did I run? So I went from -6 to 0, which is a run of 6 units. So I moved 6 units to the right and 4 units up. Now, another way you could do that is, of course, using the slope formula, which says that the slope is y2 minus y1 over x2 minus x1. And this point would be at x -6, y0. This would be at 0x, y4. So if I sub those in, y2 minus y1. So here's the second y and the first y, y2 minus y1. And then x2 minus x1. So here's the second x, and here's the first x. And if I do 4 minus 0, I get 4. 0 minus negative 6 means 0 plus 6. So I get slope is 4 over 6. Now, whichever method you use, of course, you always reduce your fractions. 4 over 6 reduces to 2 over 3. So the slope of this line is 2 over 3. Now, my line is perpendicular to this line. So that means that their slopes are negative reciprocals. So if the first slope is 2 over 3, then my slope is the negative reciprocal. This is a positive number, so my slope must be negative. This is 2 over 3, so my slope must say 3 over 2. These two slopes, because they're negative reciprocals, mean that the two lines would be perpendicular. So now I know what my slope is. So if I go over here, my line, dot, dot, has a slope of, oops, don't want to get it wrong, that'd be bad, negative 3 over 2. So I'm not going to go back to the other pages because everything I know about my line is here. My line has a slope here and a y-intercept here. So I'm going to start to create my line. And we create lines using the y equals mx plus b equation form. M is the slope. Well, there's my slope. B is the y-intercept. And I know the y-intercept, it's negative 6. I'm sorry that my b's and my 6's sometimes look the same. That's why we have to be careful with communication. So this is the equation of my line. It's in y equals mx plus b, and I know what m is, and I know what b is, so that's the equation of my line. It didn't say to put my answer in standard form, so I would be fine on the EQAO leaving it like this, but you know me, for kicks and giggles, let's put it in standard form. Remember, standard form looks like this. Everything is on the left of the equal sign, so that nothing remains on the right, and we indicate that with a 0. Everything is in this order, so the x term first, the y term second, and then the constant term. And there's a couple rules about the coefficients, or the values of a, b, and c. None of them can be fractions, and the a, the one that comes first, has to be positive. So let's start by putting everything on the left. So right now I've got only the y is on the left, but the other two terms are on the right. So let's move them to the left, and moving them means that we have to remove them from the right by applying the opposite math. So the opposite of subtract 3 over 2x is add 3 over 2x. So that's going to show up on the right, and it's going to make this disappear from the, that's going to show up on the left, and it's going to disappear from the right. Now, the next term is supposed to be y. Y is already on the left. So I'm going to leave it where it is. I just want to make sure that I indicate that it's positive 1y. Now the constant term, so I need to get rid of it from the right. So to get rid of minus 6, you do plus 6. And when I do plus 6 on the right, that disappears. So everything from the right has been removed, so I say nothing is there with a 0. So now I have everything in the proper order. X followed by y, followed by the constant. Excellent. So now I have to check the next rule. The next rule says that these a, b, and c values, which for me are 3 over 2, 1, and 6, none of them can be fractions, and this one's a fraction. So I need to make it not a fraction, and the way to do that is to remember that this really says 3 divided by 2. And I don't want to divide by 2. It causes a fraction. So to remove divide by 2, I'm going to multiply by 2. And because it's an equation, if I multiply by 2 on the left, I have to multiply by 2 on the right. And multiplying by 2 means that everything is about to be multiplied by 2. So what happens here when I multiply by 2? Well, I'll show you what it looks like, and then we'll do the math in a second. Here, when I multiply by 2, I get 2y. Here, when I multiply by 2, I get 12. And of course, 0 times 2 is still 0. And the reason why we multiplied by 2 is because multiplying by 2 and dividing by 2 is a pretty fruitless thing to do. This number, 3, if it's multiplied by 2 and divided by 2, that means it's not going to change. So why bother? So I'm left with 3x plus 2y plus 12 equals 0. And the final rule about standard form is that the leading coefficient, the first number you see, has to be positive. And in this case it's positive 3. So that's the equation of my line in standard form. There's just one more thing I want to do in this question, because why not? My equation, I'm just going to rewrite it, was negative 3 over 2x minus 6. I'm going to draw that on the graph we were given originally just to see the perpendicular nature. So, oops, negative 3 over 2x minus 6. So let's go back to the first page and let's clean this up. So the equation that we just found for my line, by the way, you finished the question, right? If this was the actual EQAO, you would have moved on to the next question a long time ago. But, you know, you're watching this to learn and get ready, so let's keep doing math. I want to graph this line. So remember, graphing a line in y equals mx plus b form works like this. We know the y-intercept is at negative 6, and here's the y-axis. So I can put a dot at the y-intercept because I know that my line passes through this point. Then I'm going to follow the instructions given by the slope. The slope says that from any point you can go down 3 and over 2 and you'll find the next point. So I'm going to go down 3 units. So the way that this is scaled, that's just a box. So down 3 and then over 2. And again, I check the scale up here. And the line that passes through those 2 points would be my line. I'm just going to put another dot on it, but you'll notice I can't fit a dot on this grid. So I'm going to go completely backwards, which is I'm going to do the thing we never do. I'm going to go up 3 and backwards by 2 because it'll give me my next point, right? Because this would be down 3 and over 2. And at this point, let me grab my ruler, which for me is a straight line tool. And I'm going to do my best, which is not that easy. Oh, that wasn't so bad. To connect those points, there's my line. And the 2 things we knew about our line is that it had a y-intercept here, boom, and it should be perpendicular. And that looks pretty darn perpendicular to the line drawn. So, hooray for math. I hope that was helpful. Again, we did a lot more than you have to get marks on the EQAO, but you're here to learn and I'm here to teach. So, there you go. See you in the next video.